Okay, so next we're going to cover sections 2.4 and 2.5, which are about equalities and conversion factors. So if you're in the class that's already done lab 2, then you will recognize this. So first definition, prefix. Okay, so a prefix is added to a metric base unit to increase or decrease the value by some factor of 10. Okay, so some examples, stuff that you've probably seen before, are kilo, milli, micro, mega. And you've probably seen like mega for megabytes. Or terabyte. So that first part is the prefix. So table 2.4 in your textbook shows you a list of all the prefixes and their equalities. Okay, so I'm just going to pull that up now so you guys can see it. So in this table, it shows you what all the prefixes are. So this column here is the prefix. So these are the ones that you're going to see the most often: mega, kilo, centi, milli, micro, and nano. We don't really use deci in chemistry very much because it's such a small conversion factor. So these are the ones that you should probably commit to memory because it's a lot easier just to know off the top of your head that mega equals 10 to the 6th or kilo equals 10 to the 3rd than it is to go back and forth to this table. Obviously, you guys can use this table on your exams or whatever since this is an online course, but memorizing at least these 6 prefixes and their values and what their symbol is will help you during an exam. So make note of their symbols. So mega is an M, so megabyte is usually written like this. So the symbol would be capital M, B. Okay, milli is a lowercase m, so millimeter would be 2 lowercase m's. And then micro uses the symbol mu, so it's a Greek letter, and you just kind of write it. I always write it kind of like an M with some curly Q's on the bottom. So these numbers are what you're going to use when you do unit conversions, and you want to convert from one value to another. So again, units of measurement for the metric system are the following. So you guys have seen this in lab, but I'll talk briefly about it here. So these are the measurement types. So length, volume, mass, temperature, and time. And then there are two systems of measurement that we use in chemistry, a metric system most often, and then the SI system, or the international standards, are the standard units that we use in chemistry. So for the metric unit for length is the meter, which has the symbol m, lowercase m, and the SI unit is also the meter. Okay, volume is liters. There's always a capital M, and the SI unit is cubic meters. And that's because volume is actually derived from length. So the symbol for cubic meters is meters to the third power. Mass is grams for metric, which is always lowercase g. And the SI unit is kilograms. Okay, so now this is where your prefix symbol comes into play. So it's a lowercase k, g. Temperature is degrees Celsius for metric. Symbol degrees C. And the SI unit is Kelvin, which is a capital K. Time, seconds, lowercase s. And the SI unit is also seconds. Okay, so that's just a brief refresher on what the measurement type is and their unit. So some examples, how do we use these equalities in order to convert from one unit to another? So you would use your table, and for example, let's say that you want to know, or you want to write an equality for how many meters are in a millimeter, or how many millimeters are in a meter. You can say it either way. So the first thing that you're going to do is put a 1 in the line where the number or the prefix is. And so that's going to be a 1. And then you're going to replace the prefix with its value over here on the left. So if we look back at our table, okay, so here's milli. So the value is 10 to the negative third. So milli equals 10 to the negative third. Okay, so now on the left side you will write 10 to negative 3. Okay, so this is your equality. Okay, so now we're going to write your conversion factor. Okay, so your conversion factor is always a fraction, and you can write it two different ways. So 1 millimeter over 10 to the negative 3 meters, or 10 to the negative 3 meters over 1 millimeter. Okay, and the reason why we write this like this is because when we go to actually use them in a calculation, then you can put them directly into the problem and use that fraction to solve. So this will make a lot more sense here in a few minutes. Okay, so next example, go ahead and try to write these yourself. So if we have meters, kilometers, liters, and milliliters. So write the equality by looking at what the value is for each, putting a 1 in your prefix, and then writing the value on the left side where there's no prefix. So I'll give you guys a few minutes to do that. Try it on your own, and then we'll go over it. You can just pause the video if you want in the meantime. Okay, so now if we look at the value for kilo, it is 10 to the third, so that's right there. Okay, so we put a 1 where our prefix is and write the value in the other blank. Okay, so 10 to the third meters equals 1 kilometer. Now, the next one, let's look at the value for milli. So again, we just did this example. Milli is 10 to the negative 3. Okay, so 1 where your prefix is, and then write value where just your unit is with no prefix. Okay, so now these are our equalities. So we need to write our conversion factors. So 1 kilometer over 10 to the third meters, or 10 to the third meters over 1 kilometer. Okay, and then for the second example, 10 to the negative 3 liters over 1 milliliter, or I'm going to have to write this below it, 1 milliliter over 10 to the negative 3 milliliter, or liters, sorry. Okay. So what you'll notice about this is that the prefixes, as long as they're the same, they result in the same value. So both examples that we did here for milli, they're the same value. They're both 10 to the negative 3. So keep that in mind when you guys are doing problems. Okay, so sometimes that can be kind of confusing way to write it. So this is just a note for you guys. So if you can recognize some of these conversions, that you can write it however works for you. So let's do another example here to help explain it. Okay, so seconds and milliseconds. So we know the value of milli equals 10 to the negative 3. Okay, so 1 millisecond is 10 to the negative third seconds. So you could also write it as 1 second equals 10 to the third milliseconds. Okay, so these numbers are the same. They're the same equality. They are just reciprocal of each other. You could also write it as 1 second equals 1,000 milliseconds, since 10 to the third is equal to 1,000. Okay, so if you can recognize that 10 to the third is 1,000, you can use 1,000 instead of 10 to the third. This is just to show you guys how to really use that table and make it make a little bit more sense. So all of these qualities are the same. Okay, so next example, if a car is traveling 85 kilometers per hour. Okay, so we need to write an equality for that. So 1 hour equals 85 kilometers. So now what would your conversion factors be? Okay. Hopefully you guys got this in your head now. So 85 kilometers over 1 hour, or 1 hour over 85 kilometers. So the way that we're writing this actually means the same thing. So 85 kilometers per 1 hour. This is the same thing as what we said here, just written out in more of a mathematical fashion. So now what we need to do is talk about how to use these conversion factors in problem solving. So this is actually section 2.6